In this video, we'll look at a rectangle class in Java. This is a UML diagram of a rectangle class in Java. Basically, it just tells us the name of the class and what fields and methods that class contains. In general, Java best practice is to make the fields of your class private so that people can only modify the state of the objects through the public methods. Unless otherwise noted in a diagram like this, we'll assume that the fields are private and the methods are public. What makes object-oriented languages different from non-object-oriented languages is that object-oriented languages encapsulate the data and the operations that access or modify that data into the same structure. And that structure is called the class. That's why the notion of a class is central to object-oriented languages. Conceptually, a Java rectangle is a graphical component that is defined by a point and two dimensions, a width and a height. By convention, the point we use is the top left corner of the rectangle. So X is the location of the rectangle's top left corner on the x-axis, and Y is the location of the rectangle's top left corner on the y-axis. Also, unlike normal Cartesian coordinates, the values on the y-axis get larger as you go down. So the bottom left point of this rectangle has a larger y value than the top left point. Note that rectangle is actually a class in the Java package java.awt. Now, we're going to implement a similar rectangle class, but it won't be exactly the same. Ours is going to be a much simplified version. Let's go through this class from top to bottom. First, we see the package name. Notice that this package name is called simplified.geometry. So this is not the rectangle class from the Java library. It's a simplified version of that. Next, we see that the class is named rectangle. And then we immediately see four private fields: X, Y, width, and height. These fields have not been initialized. We'll make sure that all of them are initialized in the constructor. Since these fields are private, they cannot be accessed from outside the class. They can only be accessed from within this class. After these instance variables, we have a no-argument constructor. Notice that this no-argument constructor simply calls through to the for-argument constructor right below it. When you're inside a constructor of a class and you want to call another constructor in the same class, you simply use the keyword this for the call. When the compiler sees the keyword this followed by parentheses, it'll automatically assume that it's a constructor call. Now let's look at the for-argument constructor. It takes parameters x, y, width, and height, and simply assigns them to the corresponding fields x, y, width, and height. Notice that when you use the variable x, for example, without qualification inside the constructor, the compiler assumes that you're talking about the parameter x, not the field x. This is because the parameter x is inside the method, while the field x is declared outside the method. So the parameter x hides the field x. This situation is easily remedied by simply qualifying x with the word this when you want to refer to the field. Finally, notice that both constructors are public, so they can be called from outside the class. The first four methods you see here are getter methods. Getter methods are a type of accessor method. They effectively provide read access to your private fields. Another type of accessor methods are setter methods. Setter methods provide write access to your private fields. We don't have individual setter methods in this class, but we do have a set size method that allows you to modify both the width and height fields at the same time. When a method allows you to modify the state of your object, we call it a mutator method. Getter methods should not be mutator methods. Setter methods are always mutator methods. Both setSize and translate here are mutator methods. setSize lets you change the width and height directly. Translate lets you change the x and y coordinates by passing in the amount that you want them to change. For example, if x equals 10 and y equals 20, and you call setSize 55, then the new xy coordinates will be 1525. Notice that this is accomplished using the plus equals operator. X plus equals dx means the same thing as x equals x plus dx. Notice that the last two methods do not return anything. They have a void return type. This is often true of mutator methods, but not always. You can have a mutator method that also returns a value, but you should have a good reason for doing that. Finally, we come to the equals and toString methods. As we'll learn in a future video, the equals and toString methods are inherited from Java's ultimate superclass, object. You should almost always override the equals and toString methods. The default behavior of the equals method is to return true if two objects reside in the exact same memory location on your computer. Here, we're implementing the equals method so that two rectangles are equal as long as they have the same coordinates and the same dimensions, regardless of where they reside in memory. The toString method prints the word rectangle, then in brackets it gives the x value, the y value, the width value, and the height value. When you're writing a class, you should write Java documentation for all public classes, fields, constructors, and methods. Basically, if it's declared public, it should have a Javadoc comment written for it. As an example, here's a Javadoc comment written for the real Java.awt rectangle class in the Java library. One thing to notice is that Javadoc comments make use of HTML tags like bracket I close bracket for italics and bracket code close bracket for code. Another thing to notice is that Javadoc comments include tags like @version, @author, and @since. When documenting a method, those tags become even more important. The @param tag must be in there for parameters, and the @return tag must be in there if something is going to be returned. Here's a class that's constructed to test the translate method. Its main method creates a rectangle object named box and makes sure that the rectangle is repositioned correctly. Notice that Java uses the keyword new to create the new rectangle object. Now let's look at what the generated Javadocs look like. In this example, we'll use the string class instead of the rectangle class. The Javadoc for the string class gives us the package name followed by the class name. It also tells us all the interfaces that the string implements. Below the solid line, it gives us the class declaration as it would appear in the code. Then it gives us the Javadoc written for the class. The constructor summary gives us the first sentences of the Javadocs written for the constructors. The method summary gives us the first sentences of the Javadocs written for the methods. If we want more information, we just click on the method name. For example, the replace method says that it replaces each substring of this string that matches the literal target sequence with the specified literal replacement sequence. Well, that might be a little confusing to just read that, so if we want more information, we simply click on replace and get this. Note that the Javadocs here were taken from a slightly older version of Java. So the document on the Oracle website may have slightly different formatting, but essentially it's the same thing. Okay, that's it for Module 1. In the next module, we'll learn how to trace through code, and we'll talk more about Java objects. I'll see you there.